everyone, I am Rama. In this video, I am going to explain Euler method to get numerical solution of ordinary differential equations. Using this method, we solve first order initial value problem subject to the given condition. Consider the initial value problem of the form y dash equals to f of x comma y, subject to the condition y of x naught equals to y naught. Our aim is using known point information, that means using x naught y naught. We want to find approximate value of y at any x without knowing the solution of the form y equal to f of x of star is nothing but y dash equals to f of x comma y. There are many analytical methods to solve first order linear differential equations. We are not going to solve this equation and we are expressing the solution in terms of x and y. Using the numerical approach in Euler method, we want to find y at any x. This formula can be derived from Taylor's series expansion. By Taylor's expansion, y of x plus h equals to y of x plus h y dash of x plus h square by 2 factorial y double dash of x plus and so on. It is very clear that if h is small and we consider more number of terms on our h's part, then it gives us a reasonably good approximation to y of x plus h. In Euler method, we consider Taylor's series up to 2 terms, that is up to order 1 derivative, so that y of x plus h is approximately equal to y of x plus h y dash of x, as y dash equals to f of x comma y from given IVP. The same can be written as y of x plus h is approximately close to y of x plus h into f of x comma y. Let us take it as 1. Now our aim is to find y at some x. That x can be taken as x1, and let us put x equal to x naught in equation 1. Then we will get that y of x naught plus h is approximately equal to y of x naught plus h f of x naught y naught. Now we are taking x1 equal to x naught plus h, so that this is going to be y of x1, which is approximately close to y of x naught is nothing but y naught plus h f of x naught y naught. The value of y at x1 is denoted by y1. So y1 is approximately equal to y naught plus h f of x naught y naught. From the given IVP, f of x comma y is known. In that we put x naught y naught, so that f of x naught comma y naught is obtained, and y naught is also given at x naught. This is also known to us, and h, this can be chosen to get x1. So this can be decided in the problem. Similarly, if we put x equal to x1 in equation 1, we get that y of x1 plus h is approximately close to y of x plus h f of x1 y1. x1 plus some h, we get the next x value, which is going to be x2. Then the corresponding y will be y2, which is given by y1 plus h f of x1 y1. In general, y at x equal to xn plus 1 is obtained from yn plus 1 is approximately equal to yn plus h f of xn yn, where n is equals to 0, 1, 2, 3 and so on. For n equal to 0, we will get y1. For n equal to 1, we get y2 and so on. This is called Euler formula to find approximate solution of initial value problem. Since we have considered Taylor's series up to order 1, the order of Euler method is said to be 1. Also, this method is said to be single step method or step by step method, since this method uses only one preceding point information. Let us see that. We know the data x naught, y naught. Using only this known information, we want to get y at some x. The next x can be taken as x1, so the corresponding y will be y1. Using x1, y1, we will find y2 at x2 and so on. So here, to find y1 at x1, we are using its previous point information x naught, y naught. Only one preceding point information is used here. Similarly, to find y2 at x2, we use x1, y1. That means again we use one preceding point information. Hence, it is said to be step by step or single step method. This is Euler method. I hope you understood this. Thank you.